Hey folks, today we're going to talk about list detail screens in iOS, and specifically we're going to talk about how to make a list of things appear on a screen in iOS. This is a relatively common task that you might need to do in any application, be it iOS or Android or most web frameworks as well, where you'll need to show a list of things. And we're going to do it starting from an empty project and build it up piece by piece. This is going to be the basis for the app that we'll be building cumulatively over the course of the quarter. So you want to start by opening Xcode, and it's going to show you this screen. You want to go ahead and make a new project. We're going to do a single view app. So click Next. And for the product name here, I'm going to do Angry Birds. We'll be making a list of birds that look angry. You want to make sure that your organization identifier is filled out, but you can make this up. And then for language, you want to choose Swift. And between Storyboard and Swift UI, we're going to continue going with Storyboard for now. Swift UI is very quickly maturing, but the majority of iOS apps right now are built with storyboards, and storyboards will continue to be supported for a long time to come. So you'll also notice some checkboxes here. I want you to make sure that include unit tests and include UI tests are both checked. We're not going to be writing tests in this specific demo, but we will be writing tests for this application in the future, and I want you to have that set up. So then we click Next. All right, so now we have the beginnings of our application. We went over some of what you see on this screen in the first session of our class. So if you're interested in learning a little bit more about this screen, I would recommend taking a look at the recordings from session 1. But today we're going to go straight over to the main.storyboard. As we went over in class, this is where you can set up the screens for your application, and so we'll be setting up our first screen here. The method that I'm about to show you for implementing a list and a list view in iOS will be different from some of the methods that you might find on YouTube or in other places. I'll explain how and I'll explain why, but essentially the method that we're talking about today will be a little bit more flexible and a little bit more useful for the purpose of teaching some of the concepts in this class than some of the maybe a little bit easier, faster ways. Okay, so now that we're on our storyboard, we need to go to our object library. We can do that by clicking this plus button up here in the upper right-hand corner, or by hitting Command-Shift-L. That's going to bring up our object library. You'll find that I tend towards using key bindings rather than clicking buttons in Xcode or any other integrated development environment. The reason for that is that way my hands can stay in one place when I'm navigating around the editor or typing code, and as I get used to the key bindings, it makes me much more efficient at whatever stack it is I'm writing in. Okay, so now inside of our object library, I want you to look for a table view. You'll see a few things here: table view cell, and table view controller. I want you to click table view and drag it onto your scene. So the next thing that we need to do is set up constraints for our table view. I want the table view to take up the entire screen, no matter the orientation or size of the device. And so I'm going to click and drag the top until it lines up with the safety margin at the top. Bring the bottom all the way down as well. And then the trailing edge and the leading edge. So now we've got our table view taking up the entire screen, and we need to cement that with constraints. Otherwise, it's going to appear exactly this size on all devices, and it'll look strange if we're in landscape mode or on an iPad or what have you. So now In the lower right-hand corner here, you'll see a series of buttons. In the past, we've used this one to make alignment constraints. Now we're going to click on the one just to the right of that one. And you'll see it says Add New Constraints. This square in the middle represents the view that you're adding constraints to, and these boxes all around represent the distance between that object and the container object. You'll notice that there are zeros in all four of these boxes. We want those to be the numbers for our constraints. So we'll click on each of these red lines, and that puts the constraints in place. We could put numbers here, and that would change where the table view appears. But we want these to stay at 0. So click, 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 click. When you have all four of them selected, this button at the bottom should say Add 4 Constraints. So you'll click that button, and now you have a table view in your application. Next, I want to open my code. So I'm going to do that with Command-Shift-O, and then I'm going to put in the name of my file, View Controller. This is the same base view controller that we were given in the 2 applications that we built during session 1. I'm going to click on my keyboard Option-Enter to open this file to the right of my storyboard. This is going to allow me to add my outlet by clicking and dragging. So I select my table view, I hold down the Control key, I click, and I drag to my code. It says Insert Outlet or Outlet Collection, so we're adding an outlet to our table view here. I'm going to name my table view, rather uncreatively, Table View. I'm going to hit Enter to connect it. So now I have a table view inside my code. I'm going to shut my assistant editor so I have a little bit more room to work here. Also going to adjust my views a little bit so that I could see things a little better. Sweet! Okay, so now we have our table view in here. That's not going to be quite enough to get our application working. We need to do some connection work in order to ensure that our app is going to display something in our table. So the first thing we're going to need is some data to show in our table. And for this, we're going to use some pseudo data to demonstrate the way that our table view is going to work. I'm going to use the name of birds, but you can use any string you want. You can even use strings that pertain to the type of data that you want to put in your final application, like the names of ingredients if you want to make ingredient lists, or the names of national parks if you want to make a national parks list. So here we go. I'm going to do var for a mutable variable here, and I'm going to call it birds. No, let's call it flock, because that's a bunch of birds, right? And the type is going to be an array of strings for now. We'll get more complicated with this later. Okay, so now in our viewDidLoad function, when our view loads to show our table view on screen, we want to make sure that our data object has some data in it for our table to display. So I'm going to make that up for now. Self.TableView. Remember, we can also reference this with just table view here, but it's good practice to put self dot because that indicates that the scope of this variable is not this specific method, it is inside of this entire class. Or rather, self.flock, apologies. Okay, self.flock. So this is going to be our data, right? Okay, so let's put Oriole, Bluebird, oops, Blackbird. And I could keep adding and adding and adding to this, but I'm going to copy and paste it a bunch of times so that I have more items in my list without spending a bunch of time on that. Great. So now we have our table view and we have our data that goes in the table view. And we need to figure out how to get that data to display on the screen. So let's go back to our main.storyboard for a second and talk just a little bit more about the way that this view needs to be set up. When you select your table view, you'll see in the attributes inspector over here, let me shut this for clarity. You'll see in your attributes inspector over here, prototype cells. It's the second option down from the top. Currently, it's set to 0. We want to set that to 1. You're going to notice that a white rectangle appears in your table view. That white rectangle represents a cell in your table, and your table will contain a list of these cells that you can scroll through to see all of the things in your table. We'll be making custom cells later in the course, but for now, we'll use the basic cell. It comes with some options set up for you. Our cell is going to need an identifier, and you'll see why as we write the code for this. But iOS is going to use this identifier to determine what kind of cell it's supposed to be displaying when. We want to put information about birds in our cell, or I want to put information about birds in my cell. So I'm going to give this the identifier bird cell, like this. We'll end up using that in the code in a minute. Okay. So now I'm going to shut my assistant editor again, Command-Shift-O, View Controller, Option Enter, it opens on the right. Okay. So, now I have my data. We'll get to that in a second. We need our view controller to implement some protocols. So a protocol in Swift is similar to an interface in Java. It is not an instance of an object, but rather a series of attributes that a class is expected to possess or methods that that class is expected to implement. It's a way to ensure that different classes subscribe to sets of functionality that they might need, and then we can say in another piece of the code, like, I don't care what specific class you give me, as long as it responds to this list of methods that I might want to call on it. There are 2 protocols that you need to implement in order to have a table view in your view controller. They're called UI Table View Data Source and UI Table View Delegate. The way that we ask in Swift for a class to implement protocols is that after the colon here, we put any protocols that we wanted to implement. If our class is a subclass of some other class, view controller, for example, is a subclass of UI view controller, then the order goes superclass, comma, protocols. Okay, so now we'll need to implement those protocols. But first we do need to fix one thing. This error says class view controller has no initializers, so the stored property flock without an initial value prevents those synthesized initializers. This becomes a little more relevant when we're talking about making our own classes as opposed to view controllers that iOS is going to instantiate. But for this reason, it needs to be possible for flock to be nil right now. And so what I'm going to do is force unwrap it. In this situation, this functions similar to the force unwrapping that we do for views that we know are going to be present when the view loads. However, when we add that force unwrap, that means it's our responsibility to make sure that that flock object always has an array of strings in it when we need it to, or else the app will crash. Okay, so now we're going to be getting a different error up here. View controller does not conform to the protocol UI table view data source. Do you want to add the protocol stubs? This means that the UI table view data source requires us to implement methods that we don't implement yet. And the IDE is going to add stubs for us when we click this fix button. So now we have these 2 methods that come from UI table view data source. I'm going to put them down at the bottom rather than at the top. And I'm going to put in a comment, mark, in all caps, data source. Here's what that gives us. Xcode recognizes this mark comment to mean that there's a heading here for something in particular that's happening inside of our file. And you'll notice that over here on the right now, we have a heading that says data source, so that when we're looking at this teeny version of the file, we can see data source in larger font. When we're talking about a really big class, that allows us to determine where in the class we might find what we're looking for. Okay, so now what are these methods? The first one, table view, has an argument of table view. That's great. The second argument says number of rows in section. iOS is going to use this to determine how large each section of the table should be. Each table can have sections, which are groups of cells, and then inside of those sections you have some number of cells. It's asking here how many cells are in each of your sections. We only have one section. One section is the default in the table views in iOS. And so the number of rows that we need is the number of birds in our flock. So the answer here is going to be self.flock.count. So now we've implemented that method. The second method that we need to implement is recognizable by the second argument, cell for row at index path. iOS is going to use this method to create each of the cells in our table view. So we need to get a cell from somewhere, put any data in it that we want displayed in the cell, and then return that cell for display. Those are our 3 steps. The first one, we need to get a cell. Now, we could new up a cell here, but we're not going to do that. And we'll talk a little bit more about why in a future demo. But for now, our table view has a method on it called dequeueReusableCell. We want to implement that. We have a set of cells sitting in a specific area of storage, and we want to dequeue a cell of the right type from that standing pool of cells. You'll notice that it has an argument with identifier. This is where we need the identifier that we included in the storyboard. Bird cell. Now dequeueReusableCell with identifier. We can take a look at this method by holding down our Option key and clicking on the method. That's going to give us this bite-sized documentation as to what this method does. This will work with any method in the iOS framework, and you can also implement this quick help for your own methods. So, what does it do? It returns a usable table view cell object located by its identifier. This is what we talked about. Now let's take a look at its signature. We talked about the name, and we talked about the identifier that we need to pass in. It returns us a UI table view cell. Oops. Come on, Xcode. But it returns us that cell optionally. If such a cell is not available, then we'll get nil out of this method. For now, we are going to assume that those cells are going to be available to us, and we're going to force unwrap the return value of this method. Okay, so now we have our cell available to us. What we want to do is we want to take our bird information and we want to put it in our cell. So we'll use our dot trick from session 1 to figure out how we might do that. On a cell, we have several attributes: accessory type, accessory view, background view, content view. We'll talk about what all of these things mean later, but I wonder if there's a title or something that we can use. So I type in title. I see detail text label. So maybe if there's a detail text label, there's also some kind of main text label. And it looks like there is. We have a variable called text label. So we'll use that. Labels in iOS have an attribute called text. You can't set strings directly on the label, but you can set them on the text of the label. And we're going to assign that to whichever bird we're at in the list right now. The way we're going to know which bird we're at in the list right now is with the variable index path, which gets passed into our table view method here. So we go to our flock and we get the bird at index path dot row. An index path actually contains two things, a section and a row. But we only have one section here, so the section is always 0. And we want the row, the specific cell in the specific order that we have for our birds in their flock collection. Typo. All right, so we've done the first two steps, right? Step 1, we got our cell from somewhere. Step 2, we added data to the cell. Now we need to do step 3, which is going to be to return the cell for iOS to display. And that's what this error that keeps bothering me is related to. Missing return in a function expected to return UI table view cell. We see here that the return value for this method is a UI table view cell, and we currently return nothing. So here, we need to return our cell. Great. So now, when we run our application, we don't see anything in our table view yet. You can see our table view, you can scroll on our table view, but it doesn't appear to be working. The thing that we've overlooked here is a thing that's really easy to overlook. And so I want you to see us fixing this, because if you run into this and you can't remember the 2 lines that are missing, now you've seen an example of how those 2 exact lines missing will look on the device. So our view controller implements the data source. It also implements the delegate, although it doesn't implement any of the methods in the delegate. We'll talk about that a little bit later. But right now, the data source and the delegate of this view controller are not set. These 2 lines are a little bit weird. So what we need to do here is our table view needs to know who is my data source and who is my delegate. Are they separate classes to the view controller? Are they the view controller itself? So we need to say the table view's data source is this view controller, and the table view's delegate is also this view controller. So it's these 2 setup commands that we need. Run it again. And now our data appears in the table view. Table views in iOS are automatically embedded inside of a scroll view. A scroll view allows you to scroll around on your screen with touches so that your screen can encompass more space than actually exists on the screen real estate of your device. So when I scroll like this, you'll notice a scroll bar appears to the right, and you can scroll down all the way to the bottom on your list. You can embed views and scroll views as well in your applications, although we don't need to for this application. You click on the view that you want to embed in a scroll view. Let's get rid of this for clarity. And then next to our constraint views, you'll see a rectangle with an arrow, and when you hover on it, it says embed in. So you can embed it in a scroll view or in another view, or in a stack view. We'll talk about stack views a little bit in a future video as well. You can also embed in a navigation controller or a tab bar controller. We'll talk about those in future videos too. Okay, so now we have our code working. There is a final step that I want to demonstrate to you. This is a feature of Swift that can be really nice for organizing our code. So if we go back to our view controller, currently we have everything listed inside of this same class. We have our view controller, it extends UI view controller, it implements the table view data source, and it also implements the table view delegate. Let's talk a little bit more about implementation of protocols and how you can organize that. So we saw an error that we didn't implement the data source methods, right? There were two required methods for implementing on for complying with the data source protocol. There are other methods on the data source protocol that we can implement as well. You can think of them as handles that we can use to open doors to more functionality in the table view. The delegate is the same way, except that none of the methods in the delegate are required for you to implement. So why are there two protocols for table views? Well, the reason that there are two is because they handle two different spheres of functionality. The UI table view data source handles the way that we display and manage the data that's supposed to be in the table. The delegate, by contrast, deals with the look and feel of the table and people interacting with the table. So when you want to decide what the table should do and how it should respond when a user clicks on a cell, that method is going to be in the delegate. When you want to determine which data should display in each cell, that's going to be in the data source. When you want to determine what swipe actions are available when you swipe on each cell, that's going to be in the delegate. When you want the iOS to know how many sections are in that table, that's going to be the data source.